All right, let's talk about energies and the different types. Buckle up because there's a lot. The objectives for this lesson, we should be able to identify which types of energy an object or system possesses and explain why the object or system has that type of energy. We also need to be able to identify the energy transformations and which are possible and describe real-world circumstances where those energy transformations take place. All right, so vocabulary. Dissipate. That just means spread out widely so that the density or intensity decreases as the spread increases. So if you take peanut butter and you smear it all over a piece of bread, you're losing the concentration of peanut butter that was once this big glob on the bread. As you spread it out, the density of the material becomes thinner. Same thing with our energy. Dissipated energy is a type of energy where the energy spreads out over time so that the energy becomes less dense and less noticeable. Efficiency is a measure of how well energy is transformed from one form to another. All right, types of energy. There are lots of different forms, like I said. Here's what we need to know about energy. Energy is a scalar quantity, which means that energy is just an amount and has no direction. Energy can be negative, not because negative represents direction, but because it's possible to be in energy debt, which we're going to go in deeper later. All forms of energy are measured in joules. Energy is a conserved quantity, which means in a closed system, the total amount of energy before something happens equals the total amount of energy after something happens. In an open system, any energy lost or gained by the system is gained or lost by another system. Energy has to go somewhere. You've heard the phrase, energy can't be created or destroyed. That's what we're talking about here. At this level of physics, there are three main categories of energy that we consider. We've got chemical energy in the form of chemical bonds. Chemical energy changes as chemical bonds are rearranged. We have mechanical energy. This is the big, huge one, which is any kind of kinetic or potential energy. Then we have dissipated energy, which is any form of energy that spreads out over time. As the energy spreads out, it becomes less dense and seems to disappear. Although the energy is still there, it's just spread out over a wide volume. You still have peanut butter on that bread. Mechanical energy consists of 5 different types of energy that we're going to explore here. We have translational kinetic energy. Translational just means that it's moving exactly like this, side to side or maybe up and down. It's the type of energy that an object has if the object's center of mass is moving. Rotational kinetic energy is the type of energy that an object has if the object is rotating. Its molecules are making circles around its center of mass. So for this unit, we're not going to talk about rotational kinetic energy because it's kind of a big thing. We're going to talk about that later on in the course. Gravitational potential energy is the type of energy a 2 or more object system has if there is a gravitational force acting between the 2 objects. Elastic potential energy is the type of energy an elastic object has if it's stretched or compressed to a length different from its equilibrium length. Electric potential energy is the type of energy 2 or more object systems have if the objects have electric charge and attract or repel, not relevant to us in this specific class. When energy is transformed into a dissipated form of energy, then the energy spreads out over a broad region. If the energy is spread out enough, then it seems like the energy disappears. Energy can't disappear, but instead it's so spread out it's not noticeable enough. Thermal energy is a type of this dissipated energy. The energy that an object with any temperature has, as long as that your temperature is above absolute zero, or 0 Kelvin. Objects with temperature have molecules that vibrate randomly. Thermal energy is actually the total of the kinetic energy of all of the moving molecules. The hotter an object, the more the molecules move as they vibrate. So in a cool object the molecules, you can think about them vibrating like this, and then as you increase the temperature, they start going faster and faster and faster. And your temperature is the average of those kinetic energies. Hot objects dissipate their thermal energy into their surroundings. you just turned off a hot plate or a hot stove, the hot plate gradually cools down to room temperature, and the room will then get slightly warmer as the thermal energy from the hot plate goes into the room. Obviously, with a hot plate, the energy is concentrated, or on a stove, the energy is concentrated to this tight little circle, but the room is enormous. So as that energy goes out, it gets spread out and seems to disappear, but it can't. The other two forms of dissipated energy come in the form of waves. Waves are physical structures that begin at one point and spread out in all directions, taking energy with them. As the wave spreads out, the energy spreads out. Once the wave is spread out enough, the energy is dissipated over a large area, so as it seems like the energy doesn't exist anymore. It does, but it's not noticeable. Sound energy is a type of wave. Sound energy is the energy that's carried by a sound wave, molecules that vibrate in a special pattern. So sound energy is a total of kinetic energies of vibrating molecules. Our ears gather air that's vibrating. That's what a sound wave is. It's just the vibration of air molecules. A speaker works by sending an electric current through a coil, and that coil then has a magnetic force that pushes the cone upwards and back downwards. So as that's happening, the speaker is vibrating the air, and then that vibration of the air is picked up by our ears. Light energy is the energy that's carried by a light wave, which is made up of electric and magnetic fields, not made up of any substances composed of atoms. So we're not going to worry about it at this level.